Imagine an exact antimatter version of yourself, living out an identical life in a mirrored universe where time flows backward. According to the standard model of physics, the Big Bang generated equal amounts of matter and antimatter. For every particle created, a matching antiparticle should exist. But in the observable universe, antimatter is completely missing. The entire anti-half simply disappeared. We also observe a universe that is highly smooth and spatially flat. Theorists explain this using cosmic inflation, the infant cosmos ballooning wildly in size, stretching everything flat. There is currently no observational proof for those initial chaotic bursts of expansion. As our telescopes have improved, our most powerful experiments have repeatedly failed to detect the long wavelength gravitational waves that inflation predicts, and the math requires an uncontrolled, unpredictable multiverse to function. Our dominant theoretical approaches rely on highly complex, unproven inflation models to describe a cosmos that powerful observations reveal to be highly ordered and mathematically minimal. To resolve these contradictions, we can look at a strict mathematical rule that successfully governs the microscopic world: CPT symmetry. CPT stands for charge, parity, and time. If you take a known particle interaction, swap the charges to turn matter into antimatter, flip the spatial parity like a mirror reflection, and run the time backward, the physics equations remain perfectly balanced and valid. Physicists Neil Turok and Latham Boyle propose scaling this microscopic symmetry to the macro level. Instead of applying it to a single particle interaction, they applied it to the entire universe, starting at the initial singularity. Under this model, the Big Bang acts as a central mirror. Extrapolating backward reveals an hourglass spacetime structure. This mirrored pre-bang half is dominated entirely by antimatter. Time still flows forward, expanding outward in both directions. They only appear reversed relative to one another. By mathematically enforcing a balanced mirrored universe on the opposite side of the singularity, the puzzle of our missing antimatter is neatly resolved. It simply expanded outward in the opposite temporal direction. Science fiction often portrays antimatter as an inherently volatile, dangerous substance. In reality, it is completely stable, only annihilating when it makes physical contact with regular matter. If you isolate antimatter, it behaves precisely like the matter we know. An anti-hydrogen atom consists of a negatively charged antiproton and a positively charged positron. Because the charges are inverted, the electromagnetic attraction pulling the orbital to the core functions exactly the same. Knowing the chemistry is identical, consider bonding two anti-hydrogen atoms and one anti-oxygen atom. They bond to form anti-water. You could pour it, freeze it, or boil it. Its physical properties are indistinguishable from regular H2O. Because electromagnetic forces are perfectly symmetrical, an isolated antimatter universe naturally cools to form anti-stars and anti-planets, and complex biological life, completely stable within its own domain. This symmetric hourglass model also generates a crucial mathematical byproduct. Observed light neutrinos spin exclusively in a left-handed direction, but the CPT symmetric model requires mirrored, heavy right-handed neutrinos to exist as well. These heavy right-handed neutrinos would be highly stable, massive, and entirely invisible, interacting with other particles almost exclusively through the force of gravity. Boyle and Turok calculated exactly how many of these right-handed neutrinos would form in the early universe. The resulting mass perfectly matches the missing gravitational glue we observe holding modern galaxy clusters together. Instead of inventing unproven hypothetical particles, the mirror universe model accounts for cosmic dark matter using the exact particles that the underlying mathematics already demand. That leaves the problem of why the observable universe is so highly uniform and spatially flat without relying on the chaotic expansion of cosmic inflation. This photograph shows physicist Stephen Hawking, whose elegant arguments for gravitational entropy quantify the number of ways a physical system can be arranged to measure its statistical probability. When Turok and Boyle extended these equations from black holes to an entire cosmology, they calculated the entropy of entire universes. The math reveals that the universe with the highest entropy, meaning the most likely probable configuration, is one that is spatially flat and accelerating in expanding. Our universe is flat and smooth because there are simply many more smooth, flat universes than curved, lumpy ones. A massive, sudden smoothing process like inflation is mathematically unnecessary. We will never touch the other half of this cosmic hourglass. To any sentient antimatter beings on the far side of the singularity, they are the standard timeline, and we are the inverted reflection. We are left with three core pillars: a universe governed by CPT symmetry, an hourglass Big Bang mirror, and heavy right-handed neutrinos as dark matter. By confronting the anomalies of the Big Bang with the known symmetries of particle physics, we construct a cosmology that requires fewer assumptions, matches our highest-powered observations, and relies entirely on the proven laws of nature.